Okay, so welcome to another fun with regression time video. I'm on part 4, which is building a regression model. In our minitab instructions for multiple linear regression, I'm dealing with the housing price GE data. So what I'm going to go through today is the best subsetting and stepwise regression models, and so the different strategies and how they work. But the first thing I'm going to do is I'm going to create 3 categorical variables that are going to be indicators for fuel type, heat type, and sewer type. And the reason I'm doing that is because when you look at fuel type, heat type, and sewer type, there are 4 different options for each of these, which is not going to work well as far as categorizing goes. So I'm going to create indicator variables for those. So we're going to go up to data. I'm sorry, not data, calc, make indicator variables. And I'm going to have to do this for all of them. So let's start with fuel type, hit OK. Calc, make indicator variables. Now I got to go to heat type, make indicator variables, calc, make indicator variables, and then sewer type. Almost done. This one. There we go. So if you notice, you've got all these extra indicator variables tacked onto the end. We're going to be using those in our model and not these 3 because they are not going to indicate correctly if we try to use them. So we already see where we're going to end up with lots of variables in this. All right. So now that we've got that all set, hey, let's go ahead and build a regression model. So we're going to choose price as our responder and basically lots of stuff. So let's go ahead and go to stat, regression, fit regression model. And in response, I want to put price. And then for my continuous predictors, I'm going to use living area. Where's living area? Bedrooms, bathrooms, and then age. So notice I'm not using my indicators for this one. I'm just, looking for some information on this. And I say to store the deleted residuals and studentized in this, and I forget why I did that. Oh, I didn't even analyze them. Let's not bother doing that in the video for fun. Let's hit OK. So I've got a lot of unusual values in here, like this has a large residual. That seems to be very extreme for my model. This means I'm not doing a great job. And the same thing is shown by your R squared adjusted. It's not doing that great. Why am I laughing about this? I don't know, because I'm awkward. All right. I know these have very high VIF. However, it appears age is not a big indicator. It's not showing up as very significant. So this isn't a great job. Let's see if we can improve upon this process. So we're going to do a stepwise regression using our indicator variables next. So what's nice about the stepwise regression is it's going to remove the indicators it doesn't need. So we're going to go to stat, regression, fit regression model. And so I'm going to include just about everything in this. So I'm going to remove some of these. So I'm going to do lot size, waterfront, age, land value, new construction, central air, living area. Where's living area? There it is, because I don't want to use these 3. College, bedroom, fireplaces, bathrooms. I'm not going to use rooms because we've already seen that bathrooms and bedrooms and rooms very much indicate on each other. And then I want to use all of my type variables because those are all my indicator variables. All right, now to do a stepwise, we're going to hit stepwise, pretty obvious there. And then I'm going to choose backwards regression. So what this is going to, not forward, backwards elimination, is it's going to remove based on p-value for the largest. Now, this alpha to remove, that's like your minimum for removal. And I'm going to change this to 15 for funsies. And what that's going to say is when it looks at your p-values and compares them to 15%, that's the dudes it's going to take out. And the other thing I'm going to change this to is I'm going to include details for each step so that I get the details. You don't have to do this, but it'll give you more information about what it's removing and why if you do that. Let's hit OK twice, and it'll start producing your model. Wow, that ran faster than I thought it was going to. Usually this takes a while. Maybe I just have a good computer. Probably. Okay. So let's take a look. Actually, let's look at the model summary first. R squared's a little bit better. R squared adjusted. It's doing all right. It's okay. No big deal. And then it gives you the p-values of the variables that it kept in, along with their VIF, so you can take a look at this and decide if there's anything else you might want to remove, like You know, maybe bedrooms, but it's about 4%. It's not great. Anyway, so if you go up here, it gives you, notice how it's starting to say step 5, step 6, step 7. It tells you which steps and what it removed in there. So you can follow these blank spaces to figure out who it got rid of and why. So in step 1, it looked at these and said, holy crap, I don't need heat tight 2. Donk, gone. Okay, and then it looked at it and said, well, it appears that, you know, I should probably get rid of sewer type 1 next. There we go. And then it looks at its p-values and it's like, hey, look who's big. It's fireplaces. Let's get rid of that. And then it shows up again and it says, ooh, well, it appears I have a very, very, very large p-value for sewer type 2. So it appears sewer type had no effect at all. Darn. Oh well. Only one way to find out, and that's to let it step it through. And there you go. So that's what the stepwise regression looks like. This is probably my favorite one. Again, it's a little more time consuming, but it does slowly eliminate you down until what you want. Or if you want to use minitab's version of it. Now, to do best subsets, if you go to stat, regression, best subsets, you have to do the same thing. Price, free predictors. I'm going to select everything. And I want to avoid my sewer type stuff. Living area, college, bedrooms, fireplaces, bathrooms, not rooms, and then all these guys. Select. Now, free predictors are going to be the ones that allows itself to gain and remove based on what you're doing with its best subset model. Predictors in all models, this is a little weird because, well, these are the ones that you want to make sure don't have the possibility of removal. So if you really strongly believe that like lot size is going to have a huge effect, you should put it in here because then it won't be possibly removed from there. This is going to take a while. Or maybe not. I've never really tried this big one on the computer. This computer. We'll see how it goes. Oh no. It may take a long time. Yep. Okay. I picked too much junk. Darn it. Okay. Oh, hold on a second. I tried this with a different data set and it went okay. We're going to choose some smaller stuff. Let's remove a bunch of these. So let's remove age because we're pretty sure that's not going to happen. In fact, waterfront doesn't do much either. Let's get rid of new construction, central air, keep living area. I'm hoping to reduce this down to something it'll actually use. Okay, let's try this now. Yeah, I know, right? Darn it! Okay. That's the other downside to best subsets is sometimes it doesn't work at all. Okay. Best subsets on the wine data does work, in case you were wondering, because it is a smaller data set, and I think I will record a separate video on that, because this one is starting to get long. Bye!